Now that I've lost everything to you, you say you wanna start something new, and it's breaking my heart you're leaving. Baby, I'm grieving, but if you wanna leave, take good care. Hope you have a lot of nice things to wear, but then a lot of nice things turn bad out there.
Assalamualaikum warahmatullahi wabarakatuh and hi. Good morning. So morning because my time now is 6:42 p.m. So today is the 29th of Ramadan. Okay. Alright. We continue our discussion on wave equation. So now we are going to discuss about wave equation. Okay. In a wave equation, we need to recall the solution of heat equation, especially on this one, X solution. Okay, so recall the X solution. The X solution of heat equation, we have B sine n pi X over L. Okay, and T is AE negative K beta T. So we are interested on this one, the X solution. Okay, so in X solution, we need to find what? We need to consider the boundary condition of X, kan? We just need to consider the X dimension, and then we find the correct value of the eigenvalue, the K, kan? K, is it K equals to negative R square, or K equals to 0? So the answer is when your K equals to positive of R square, where R is greater than 0. So when K equals to R square, we find that the value of R is n pi over L. If I'm not mistaken, betul lah, n pi over L. And then when R square, so that we have n square pi square over L square. Okay, but the solution here is we just need to find the R of your general solution, so that we have B sine Rx, which is B sine n pi x over L. Okay, so please recall the solution of heat equation. If you don't remember, so please check the second part of heat equation. Okay, video. Alright, so we continue to the wave equation. So what is wave equation? Wave equation describes the propagation of wave. Okay, the propagation of wave, which is given by U. So U here is not heat anymore. Okay, U in wave equation is the propagation of wave. Okay, at the position x and time t. Okay, so that we can see that wave equation is given by U sub tt. Okay, U sub tt equals to nu square U sub xx. Okay, so we say that U is our dependent variable, which is later on we want to find the solution of U. Okay, x and t our independent variables. Okay, we have two independent variables, and nu is the phase velocity of wave. Right? So this is our wave equation. This is our wave equation, and note that in the wave equation, both sides of the equation consist of second order. Okay, second order. So now take a look at what we have in wave equation. Okay, so this is a partial differential equation. The wave equation involves partial differential equations, where both sides of the equation are partial derivative. Okay, and then since we have second order, but this time both sides of the equation are second order, we need to consider these three boundary conditions. The first two conditions are just like we have discussed in heat equation. Okay, U0t and ULt equals to 0. Okay, Ux when t equals to 0 is a function of x. This one kan. Okay, the new thing here is, okay, the addition in wave equation is the last boundary condition, which is U sub t. Okay, when t equals to 0, along x from 0 to L, okay, is given by a function of g as a function of x. Alright, so that what I can say is, here I have question or E. Okay, this partial differential equation consists of question or your equation of wave, and then you are given the boundary conditions, and then you have the solution. Okay, the solution by using SBM, the product solution. We can apply the SBM because of we have two independent variables. Okay, the equation is homogeneous, and we note that this equation is just a linear equation. So we can apply the SBM, separation of variables method. So complete, we have question, we have boundary conditions, and we have the solution. So in order to get the solution, we must begin with the solution. So what is the solution? The solution is this one. Inilah solution kita kan. Kan, penat berbuih dah cakap kan. So this is our solution. Okay, in order to get the solution, begin with solution. So our left hand side of our equation, we want u sub t, so differentiate twice your u with respect to t, so that we have this one. And our right hand side for our equation, we want to find u sub xx, so we differentiate u with respect to x twice, so that we have this one. Okay. Alright, so I don't want to discuss how we get the second derivative here, because benda ni kita dah discuss on our previous videos kan. So tak perlulah nak cakap banyak kali kan. Bukan awak pun bukannya tak pandai. So please recall and re-watch the videos. Alright. Re-watch, macam pelik kan. Watch again the videos. Alright, so the next step is we substitute again into our Q or E, so that we have this one. And then by using we try to separate the variables. Okay, separating the variables, we have this one and this one. I bring the new square to our left, and I just leave my x variable like this. Okay, so when I have 1 over x, d square x dx square equals to negative k, this is just like we have discussed previously in here. Kan, kita dah discuss dah sebelum ni. We have already discussed this one. Okay, right. Mana dia? Bismillahirrahmanirrahim. This one. You see? Kita dah discuss pun dekat sini. This one. This part. Okay, and then we already get the solution. The solution is ta-da-da-da. Look at the solution. Bismillahirrahmanirrahim. Okay, so the solution is this one. Mana? Okay, ni, this one. This is our solution. This one. Okay, B sine n pi x over L. When you have the u of heat equation, we have this one. No, we don't want to consider this one. So the solution of x is this one, B sine n pi x over L. So we know that we will get the same solution here. Okay, after this lah. Okay. So next step is we try to separating the variables and equate to negative k. Then we have this one. I divide or split the equation into two. I solve it separately. For the x variable, we have discussed on heat equation, so that we have this equation. And then we need to consider the boundary conditions, the first boundary conditions. Okay. By considering on the x dimension. Okay, and then we choose the eigenvalues, correct eigenvalues, k equals to r square, so that this is our new equation. Okay, instead of talking about this one, okay, we have this one. Okay, so that after we try to find the roots, okay, we find that k equals to r square, where r square equals to n square pi square over l square. And then this is our characteristic equation kan. So ini kita dah discuss on heat equation. So I just end up with the solution. The solution of x is given by, sebelum ni kita guna b sine n pi x over l. So it's just a matter of constant. I write the solution as a sine n pi x over l. So it is done for x. X solution is done. So we move to the new thing that we want to discuss on wave equation. Okay, since t here, okay, t, for the variable t, we have 1 over nu square t, d square t, dt square equals to negative k. Just the same thing, we try to rearrange the equation until we get the standard form of second order linear differential equation, so that we have this one. Okay, for this time, we don't consider any boundary condition for t, okay, the capital T, so that we can simply transform this equation in the form of characteristic equation, so that we have this one. Okay, ay double prime plus by prime plus cy equals to 0. So we have am square plus bm plus c equals to 0, right? So when you try to compare, okay, with the standard equation, we get this one lah. Okay, so we want to find the root of m, the roots of m, so that we have two complex roots, okay, where our alpha equals to 0, our beta is n pi nu over L. Okay, so we have the solution of this one. This is just like we did on heat equation, but this time we have t, not x lah. So this one is also t. Okay, so now we already found the solution of t. T of t also done. So we can find the solution of u. The solution of u here equals to x dot t. Okay, our x, what is our x? Our x is b sine n pi x over L. Okay, dot with the solution of t, this one. Okay, since we have the solution here involve n tau, n. So it means that we have infinite series solution. So when we have infinite series solution, so recall the Fourier series lah, senang cerita kan. So that you need to modify sikit, okay, do some modification to our solution here. So the correct solution of u is this one. Put the summation n from 1 to infinity. So b, okay, b dot c, I just name it as an, okay, not d or not f, g, h, and bukan constant tau, because we have infinite series of solution. Alright, so b dot c equals to an. So we plug in the cos here, okay, so I multiply this one, okay, with this one. So b dot d is bn, so bn. So I plug in sine here, and do not forget we have another sine n pi x over L, so the x term here, okay. So that this is the solution of wave equation, panjang kan, okay. So what is an? An is given by this one, the series, this one, 2 over L, integrate from 0 to L, fx and f pi x over L dx, and then our our bn is given by this one, 2n pi nu, and then take the limit from 0 to L, gx. This one is fx, this one is gx. Okay, so from the question, okay, we know that the standard equation is nu square tau, nu square here with equation. But when you want to find the bn, it just requires nu. So you must get the square root of nu square and then put it here. What is gx and what is fx? Gx and fx can be found from your boundary condition, which is this one, fx and gx, and then plug in into your integration here, into your integral, okay, put it as your integrand, and then you get the solution of an and bn, then only you plug in here. Okay, so that is the solution of wave equation. So probably you need to do a lot of exercises on this wave equation. Kena banyak practice tau. You must always practice. If we ask you on the examination, so of course for this question from A to Z, you try to solve for this wave equation. Memang markah dia banyak, and of course dia masa dia pun panjang. So please make sure that you practice a lot, okay, on wave and as well as heat equation. Dia panjang because dah lah you nak try verify, okay, and then you end up the solution tak habis lagi. You must apply the Fourier series here and then plug in into your solution of u equals to x dot t. So memang panjang lah. Okay, so that is the explanation on what is the wave equation is. Probably you can understand, and inshallah we'll discuss some exercises, but I give me time to do all the exercises. Yeah, all the best student, good luck, and Assalamualaikum.
Ooh, baby, baby, it's a wild world. It's hard to get back.